Noam Chomsky is absolutely a towering intellectual figure in our era and in any era. He's had enormous impact on the fields of linguistics, philosophy, cognitive science, and by extension, psychology. And also, he's had great prominence as a political commentator and activist. He's published, I think, over 100 books and countless articles. Noam began studying linguistics in the 1940s. He was a student at Penn, University of Pennsylvania, where he ended up studying with Zelig Harris, one of the most prominent figures in American structuralism. From 1951 to 55, he spent some time at Harvard at the Society of Fellows, where he worked on what ultimately became major unpublished book for many years, The Logical Structure of Linguistic Theory. It used to circulate in mimeographed form and eventually was published, I think, in 1975. After his time at the Society of Fellows, he moved along Massachusetts Avenue to MIT, where he taught for most of his career. In terms of landmark publications, aside from the logical structure of linguistic theory that I just mentioned, maybe some of the touchstones within linguistics have been the publication of Syntactic Structures in 1957, which was for many people their first introduction to generative transformational grammar. His 1965 book, Aspects of the Theory of Syntax, fused his theory of generative grammar with a new approach to linguistics in general that proposed to integrate linguistics into the cognitive sciences more generally. I realize I should have also mentioned in this context his 1959 review of B.F. Skinner's book, Verbal Behavior, which had enormous influence not only among linguists, but also among psychologists who are interested in the representation of knowledge of language in the mind. And was, by many people, considered one of the landmark events in the decline of behaviorist psychology as opposed to more cognitive psychology that we see today. Beyond that, his 1981 book, Lectures on Government and Binding, reinvented the field. That came along at the time when I and many of my contemporaries were at MIT. But one of the amazing things about Noam is that he's always reinvented the field again and again. This happened again in the 1990s with the development of the minimalist program. And the minimalist approach to linguistic theory has undergone repeated revisions, many of them quite fundamental, as Noam's ideas have developed and progressed. So you're all here to hear him and not me. So without further ado, please join me in welcoming Noam Chomsky for this mini course.
What I'd like to do in these lectures, which is actually just one continuous talk, break it up into parts and get as far as we can up to contemporary work and problems, if we make it. I'd like to discuss the state of the generative enterprise, as it's been called by some of its leading practitioners, what's been accomplished, what the problems are, what we can hope to see in the future. From the origins of this initiative, which incidentally revived tradition that had long been forgotten and was unknown at the time. But from the origins, the Holy Grail was genuine explanations of fundamental properties of human language, of the faculty of language. And that's not such a simple matter to capture properly, and to the extent you can, it's been an elusive goal. And I think the present moment is unusual in the history of the long history of the field, 2,500 years, in that goal, I think, seems perhaps within reach. And if that's the case, it would be a matter of no slight significance, not just for linguistics, but beyond. Well, these are the questions I'd like to explore in this extended lecture. So to begin with, we have to clarify some basic questions, highly contested questions about what the field is about, what's the nature of the enterprise. I've personally always found it helpful to rethink these matters over and over. I hope you will too. So to begin with, let's begin with what sounds like the simplest question, namely, what is language? Well, that question is plainly consequential. The answer to it will determine what we focus on, what kind of work we do, how we proceed, what counts as a result, and critically, what counts as an actual explanation, a genuine explanation. There have been many proposed answers over the years. They differ in interesting ways. And if we think about it a little, the question turns out to be not so simple. So suppose, for example, we ask the question in some other discipline, let's say physics. We ask, what is the physical world? What is energy? What is mass? What is work? Any such question. The answer that we'll get is some technical definition internal to an explanatory theory. So we won't get an account of what people intuitively think of as the physical world or think about energy and so on. That's not to the point. We'll find answers within a particular explanatory theory. Suppose we ask biologists, what is life? There it'll be a little bit more ambiguous because the theoretical understanding has not reached the point where it's obvious what the essential conceptual notions are, so it's exploratory. Suppose we ask, what is thinking? Well, here it gets a little more complicated. Actually, as you know, the question was posed by Alan Turing in a famous paper in 1950, which initiated the field of artificial intelligence. And the paper's about whether machines think. And he starts off by saying that the question is too meaningless to deserve discussion. So he's not going to discuss it because the notion thinking is so vague and amorphous that you can't give a response in the manner in which you might in, say, physics or even biology. When he's asked what thinking is, he says it's some kind of buzzing in the head, but nothing much more to say than that. So what he does is something quite different. He proposes a notion which he says might be somewhere within the range of what people call thinking, and maybe it's a useful notion. He suggests that it is, and in particular it might stimulate the development of new software and new machines. That's the famous imitation game, so-called Turing test. Well, so let's go on and notice that when you ask the question, what is thinking, what is language, what is meaning, what is belief, and so on, the answers that you get are really what philosopher Charles Stevens once called persuasive definitions, saying, here's what I think is interesting in the general domain of this loose notion. Here's something I think it's worth looking at. Well, go back to the Turing test. Notice that it's not an attempt to explain and understand anything about meaning, rather thinking. It's about an attempt to simulate some of the aspects of thinking. That's quite a crucial difference. Didn't seem so crucial in Turing's day, but now it's highly crucial, since a good part of what goes on in the study of language and cognitive science, the up north, the Silicon Valley version of this is basically simulation, not efforts to understand and explain. And in fact, that's the direction that AI and deep learning have taken. There's a lot to say about that, but I'll put it aside unless it comes up later. Well, so when we ask about these things, we're basically told, here's what I think is interesting. Okay, then the next question is it interesting? Is it a sensible choice? And if it is a sensible choice, how can you proceed to place it within the framework of some kind of explanatory theory? And insofar as you can do that, you can discuss the validity of the concept that's proposed. Other than that, there is lively debate about what is language, what is meaning, what is belief, but it's basically, here's my preference. It's not a clear thing that you can give an answer to. You can ask if the preference is a sensible one, where can we develop it, and so on, but there aren't questions of sort of validity or invalidity. Sometimes it's useful to develop a new technical term to make that clear, and that's what I'll be doing here. So let's go back to the question, what is language, and have a look at some of the preferences over the centuries. I think if you look, you can roughly say that they fall into two major categories. One approach to what is language considers the concept that we're focusing on to be something internal to a person. So my language is something that's up here. It's the buzzing that goes on up there in Turing's terms. That's one concept of language. The other concept of language is it's something external to any person, which people make use of somehow. I think we can, terminology is often imprecise, but I think you can roughly see this distinction. And what kind of work we do and how it's evaluated, all of that's going to depend crucially on which of these enterprises is undertaken. So a classic illustration of the first kind, language as an internal object, is, I think, one of the best, clearest exponents of this is great linguist Otto Jespersen, about a century ago. He was actually the last representative of a long tradition. So for Jespersen, I'll quote him, a particular language is a system that comes into existence in the mind of a speaker on the basis of finite experience. This internal system in the mind yields a notion of structure that is definite enough to guide the speaker in framing sentences of his own, crucially what Jespersen called free expressions that are typically new to the speaker and the hearer. And then there's a more general concern of linguistic theory, and that is to discover what he called the great principles that underlie the grammars of all languages. That's not generalizations about them, but the principles that underlie them. That's the first approach that regards language as a property of the person. The second approach is illustrated by the structuralist behavioralist approaches to language of the first half of the 20th century, still, of course, continuing. That took language, that's the object of study, to be, say, a corpus of materials that a field worker would elicit from an informant, or perhaps an infinite set of sentences, or some other entity that's external to people. So if you look at the actual formulations for de Saussure, founder of structural linguistics, a language is a kind of a social contract in a community, some collection of word images in the minds of the people of the community. Go to the leading American linguist of the early half of the 20th century, Leonard Bloomfield. Language is this, he asked the question, what is language? Language is the set of utterances that can be spoken in a speech community. So something out there. Go to philosophy of language, perhaps the leading philosopher, most influential philosopher of language of the mid-20th century, Van Quine. Language is a fabric of sentences associated with one another and with stimuli by the mechanism of conditioned response. Elsewhere, I said a language is an infinite set of sentences which people use. David Lewis, another influential philosopher, took the same view in his important article, Language and Linguistics. A language is an infinite set of sentences used by a population. Both Quine and Lewis, very good logicians incidentally, both concluded that while it makes sense to say that a population uses this infinite set, it doesn't make any sense to say that there's a particular way of characterizing the set. That, in fact, Quine said would be folly to look for that. These are, if that's what language is, then what's linguistics? Well, linguistics naturally would be a way of taking data, however you get it, typically from an informant, applying various procedures and methods, and getting an organized form of that data. The most sophisticated version of this was, as Tim Stoll mentioned, Zelig Harris's Methods in Structural Linguistics. In Europe, Trubetskoy's Principles of Phonology was constructed on similar grounds. Well, these are all, this characterizes almost completely the structuralist, behavioralist approach to language. There's something kind of paradoxical about it. So what is this? What are these entities? What is the set of sentences spoken in a speech community? How can members of a population use an infinite set unless they have some way of determining what's in the set or out of the set? In fact, how can we even coherently talk about an infinite set unless we have a method of characterizing it? So it seems to me, at least, that the approach of leading philosophers and logicians was kind of confused. It's really the opposite. You have to be, if you want to talk about an infinite set, you first have to discuss what the internal mechanism for characterizing that set, what's been called an I language in modern terms. Well, whatever these ideas are supposed to mean from the structuralist behavioralist period, which I think is not easy to answer, but whatever it is, there's something external to people, which people have some relation to. Now that by no means has ended, so right up till the present there are strong currents that take very similar views, and I think one can ask the same questions about them, including within, roughly speaking, the generative enterprise. Well, suppose instead we adopt Jesperson's view, which I will do, then the linguist is studying something that's in the mind of the speaker, namely the mature state that has been attained by, that has, in Jesperson's terms, come into existence, and also the innate endowment of the speaker, the faculty of language, which makes possible which first of all determines what Jesperson's called the great principles that underlie the grammars of all languages, and also makes possible the transition from finite data to the state attained, to the I language. In modern terms, it's as I said, the mature state attained is called the I language, internal language, technical terms, and the innate principles are nowadays called universal grammar, UG. That's taking a traditional term and adapting it to a new context. Well, it's the term, the letter I in I language is convenient. It refers to the fact that the internal language is, first of all, internal. Secondly, it's individual. And thirdly, it's intentional with an S. We're interested in the actual procedure, the actual algorithm, not the set of things that it does. So, for example, if you're studying, say, knowledge of arithmetic of a person, say you want to know exactly how that person carries out addition. You're not talking about the set of triples x, y, z, such that z is the sum of x and y. Here, too, we want to understand the generative system in intention. Well, I should say that with regard to universal grammar, there's a good deal of confusion, which is right up to the present, which is worth dissolving. It's very common to hear that UG has been refuted or that it doesn't exist. That presumably means, what people presumably mean by that is that generalizations about language have exceptions, which is of course true. That's true of generalizations. But that's not what UG is about. UG in the contemporary sense is about the innate endowment that enables this transition that Jesperson talked about from finite data to the concept of structure in the mind. The concept of structure now is what we call the I language. So it should be clear that to deny the existence of this is not debatable, it's senseless. If it doesn't exist, language acquisition is magic. There is a kind of coherent version of this common claim, Tomasello, many others. A coherent version would be to claim that there is some general learning mechanism which has nothing specific to do with language, or maybe some collection of cognitive capacities which integrate somehow to make it possible to achieve the properties of language, what the faculty of language did. There's a couple of problems with these proposals. One problem is simply that they reduce to hand-waving, or if they're made at all explicit, they're very quickly refuted. A second problem is that you can expect in advance that they're not going to work for reasons that were discussed by Eric Lenneberg in his classic book on faculty of language, biology of language, 50 years ago, in which he pointed out, he discussed the fact that there are double dissociations between language and other cognitive processes. This work has since been greatly extended. Susan Curtis is the person who's done the most extensive work on this. And in fact, there are many examples of cognitive capacities intact but no language, and conversely. So it's pretty clear in advance that it's not going to work, but it's nevertheless a widely held view. So I think it doesn't really make sense, as far as I can see, to claim that there's some problem about UG. Well, go back to Jespersen, the position that I want to continue with. Jespersen was the last representative of a very interesting tradition, which goes back to the origin. It originates back in the 17th century scientific revolution, which set the course of modern science in a sharply new direction. The great thinkers of the 17th century, Galileo's contemporaries, others, they simply refused to accept what happens around them as being natural, self-explanatory, not requiring explanations. They recognized that the phenomena of nature were puzzling, mysterious, and demanded explanation, whether it was objects falling to the ground or perception of a triangle or anything else. That willingness to be puzzled about phenomena was actually something pretty new that had happened under the Greeks. It was kind of a dark ages that followed, but it was revived by the 17th century thinkers. And as soon as they began to look around them, they found that everything was really puzzling, and things that seemed obvious did require explanation. Actually, something similar happened in the 1950s. If you go back to that period, linguists generally assumed that everything was more or less understood, and that there was nothing general that you could say about language. A famous characterization by theoretical linguist Martin Jost, what he called the Boasian principle, named after the great anthropological linguist Franz Boas, is that languages can differ in arbitrary ways. Each one has to be studied on its own without preconceptions. There's nothing to say about language except applying the procedures to a corpus, and you could do that. So essentially the field was terminal. Actually, I was a student at that time, and the general mood among students was, this is fun, but what do we do when we've applied the procedures to all the languages? Then it's over. As soon as he began to undertake to look at the phenomena seriously, to try to construct actual generative grammars which would work, you found out that you didn't, it's not that you understood everything, you understood almost nothing. Everything was a puzzle, and it didn't seem as if there'd be any termination to the field, and that's what's happened since. By now, it's just exploded since, and the kinds of problems that students are looking at today, you couldn't have even formulated, let alone dealt with not many years ago. That's an enormous change. Well, let's go back to the 17th century. Among the many phenomena that intrigued and puzzled Galileo and his contemporaries, one actually was language. So they were struck by, in fact, they expressed their awe and amazement at a quite remarkable fact that, as they put it, with just a few symbols, a couple dozen symbols, it's possible to express an infinite number of thoughts and to convey to others who have no access to our minds all of the workings of our minds. And they asked how that magical accomplishment could be made. I like to quote their own words, which puts it evocatively. They were awed by the method by which we are able to express our thoughts, the marvelous invention by which, using 25 or 30 sounds, we can create the infinite variety of expressions which, having nothing in themselves in common with what is passing in our minds, nonetheless permit us to express all our secrets, allow us to understand what is not present to consciousness, crucial point, in effect, everything we can conceive and the most diverse movements of our soul. And if you stop to be willing to be puzzled, it is a pretty amazing fact. It's by no means seems natural. Yeah, we do it all the time, but it is quite amazing. Furthermore, there's nothing similar to it in the organic world, which they recognized, which raises very crucial questions. How did this unique human achievement come about, and how can it be understood and explained? Well, for Galileo, the alphabet was, he said, the most stupendous of all human inventions, comparable to the achievements of Michelangelo or Titian, nothing like it. The reason was, first, that it captured this amazing property, and secondly, because it allowed us to express all the wisdom of the ages. And beyond that, it included the answers to any question that we could pose, all in this small collection of symbols. It was kind of like what we would call these days a universal Turing machine. The Port Royal Grammar and Logic, which followed shortly after, gave many serious insights into logic and linguistics, became the basic logic text for many centuries. It initiated a tradition in linguistics of what was called rational and universal grammar. Rational because it was seeking explanations, not descriptions. Universal because it was trying to find the principles that underlie all languages. Jesperson's great principles that underlie the grammars of all languages. Well, the traditional formulations are not precise, but I think it's fair to interpret them as recognizing that the capacity for language, as well as individual languages, are internal properties of persons, as Jesperson says quite explicitly. And it was also generally assumed, without much evidence, but as we know now quite reasonably, that this capacity, whatever it is a human characteristic shared among all human groups. There are no known group differences in this capacity. And it's furthermore unique to humans in all essential respects. There's nothing analogous in the organic world. So it's a true species property, and as they recognize, it's the foundation of human culture and human creativity. Well, these ideas actually had a very substantial impact on philosophy and general intellectual culture, mainly through the influence of Descartes, who adopted similar views roughly the same time. Descartes' famous dualistic approach, the idea that in addition to the material world, there's also a mental world, was based very substantially on the recognition that this unique capacity of ability to create an infinite number of thoughts is somehow unique to humans, and it cannot be captured by machines. Machines for early modern science, Galileo through Newton and beyond, meant the kinds of artifacts that were being created by skilled artisans and were proliferating all over Europe, very complicated artifacts. They could do all sorts of intricate things, and their approach to science is, well, that's what everything is. It's called the mechanical philosophy. Philosophy, of course, meant science. So mechanical science is, that's real explanation. The criterion for intelligibility for Galileo and his contemporaries was constructing, or at least devising in principle, a machine that could account for something. If you could do that, you had an intelligible theory. But Descartes recognized quite correctly that This capacity, this amazing capacity, couldn't be captured in those terms, so postulated a second substance, res cogitans, thinking substance, which would capture this capacity somehow and be linked to the material world. That's Cartesian dualism. Well, the Cartesian scientists took this next, this is all a scientific program, perfectly sound science, based on correct observations about the limits of mechanical objects. The Cartesian scientists took the natural next step, especially Jacques de Cordemois, leading Cartesian philosopher, scientist. De Cordemois designed experiments, series of experiments, to determine whether some other creature could exhibit the capacities that a human can exhibit. This sounds sort of like the Turing test, but with a crucial difference. Turing was trying to find something that would simulate aspects of human behavior. De Cordemois was pursuing a scientific project. It's kind of like a litmus test for acidity. Does some other entity, some other object or organism have a particular property? It's a similar looking project, but very different in character. This is real science. Well, what happened to these developments? Their fate is commonly misinterpreted. It's often believed that science, as it developed, got rid of what Gilbert Ryle called the ghost in the machine, the second substance. But what happened actually is the exact opposite. What happened is that Isaac Newton, much to his dismay, exorcised the machine, but he left the ghost intact. Newton showed that there are no machines, that there's nothing, the material world simply cannot be captured in mechanical terms because of interaction without contact, which is inconsistent with the mechanical philosophy. Newton himself regarded this result as a complete absurdity, which no one with any scientific understanding could contemplate. He agreed with the other great scientists of his day, Leibniz and Huygens, others, that this was utterly absurd, but couldn't seem to find a way out of it. So the end result is we have theories like Newton's that we can understand, but no intelligible world. What they describe is simply unintelligible. That was understood, and science just changed. It stopped seeking intelligible accounts, an intelligible world, and just moved to the weaker objective of finding intelligible theories of the world, which is quite different, quite unacceptable to early modern science. It's a major shift in intellectual history, and it was understood, very well understood at the time. So shortly after, David Hume, who regarded, writing in his History of England, has a chapter on Newton, greatest genius in history. He says, while Newton seemed to draw the veil from some of the mysteries of nature, he showed at the same time the imperfections of the mechanical philosophy, and thereby restored nature's ultimate secrets to that obscurity in which they ever did and ever will remain. And they do, in fact, remain in that obscurity. Science just stopped looking for them after some period. John Locke, shortly after Newton's great volume appeared, the great treatise, Principia, Locke carried the information further in a highly consequential way. He expressed it within the theological framework of the day, but we can change the terms. The point is correct. He argued that the incomparable Mr. Newton, as he called him, had demonstrated that God had added to matter properties that are inconceivable to us, specifically interaction without contact. And so perhaps God had superadded to matter the capacity of thought, a property of certain kinds of organized matter. That's thought. That idea was pursued extensively through the 18th century into the early 19th century. Darwin mentions it in his notebooks. Was then forgotten completely, and it's been revived in recent years as what's called a radical new idea in philosophy of mind. It's now a commonplace of the cognitive and brain sciences, picking up a forgotten tradition that followed directly from Newton's demonstration that there are no machines. It's a crucial part of intellectual history, not too well understood. And it's worth remembering that, as Hume and Locke correctly recognized, Newton had in fact left issues in mysteries in obscurity in which they remain. That's quite an interesting question. Well, let's put that aside and go back to the tradition of rational and universal grammar, culminating in Jespersen. All of that was swept aside completely by the 20th century behavioral structuralist currents, which typically, in fact, I think universally, adopted the second approach I mentioned, taking language to be something external to people, which people somehow grasp. The whole tradition was totally forgotten, still unknown, which is unfortunate, I think. There's a lot of wealth and richness there. It was so forgotten that even Jespersen, famous linguist of the early 20th century, was gone. There's an interesting article by a historian of linguistics, Julia Falk, who reviews this and points out there was just even the major linguists like Bloomfield and others just knew nothing about it, essentially nothing. Well, that general program that culminates, say, from roughly Galileo to Jespersen, that falls within the natural sciences. It was revived with the generative enterprise in the early 1950s. It's called the biolinguistics program, but it should be understood that this is only one current within the generative enterprise. Much of the ongoing work within the generative enterprise does not accept this internalist view, but that's the one I'll keep to. Well, the early efforts in the tradition ran into plenty of difficulties, empirical difficulties, conceptual difficulties. The empirical difficulties were that there just wasn't enough evidence. What was understanding of language was pretty thin. The conceptual problem was that there was no way of really understanding this notion of concept of structure in the mind that enables this achievement of expressing an infinite number of thoughts to be captured. Well, all of that was somehow they recognize there is what we may call the basic property of language, reformulating it in our terms. Somehow this concept of structure in the mind is capable of generating an infinite array of structured expressions, each of which captures a thought to the extent that we understand the notion thought, and each of which can be externalized in some sensory motor modality. Typically sound, but as we know now very well, could be some other modality. Could be sign. Sign is virtually identical to speech, even with some reservations, could be touch. So it's modality is basically irrelevant, a matter of some significance that I'll come back to. Well, by the mid-20th century, the conceptual problems had been overcome. That's why the generative enterprise was able to take off and revive the tradition. Turing, Emil Post, Gödel, of course, other great mathematicians had given a precise, clear understanding of what became the theory of computability. which allows us to understand very clearly how it can be that a finite object like the brain or your laptop, for that matter, can capture within it the basic property. Now that's well understood, which means you can proceed with the enterprise that had lapsed with Jespersen. Well, that you can deal with what sometimes I've called the Galilean challenge, the original formulation of what the field, I think, ought to be about. It's a persuasive definition again, but you can decide whether you like it or not. Well, if you want to meet the Galilean challenge, there are several tasks. First task is to try to discover the I languages for languages of the widest possible typological variety. It's a huge task, of course. Second, having done, to the extent you can do that, you can turn to the next problems, theoretical problems. The first one is to determine how a speaker of a language, when he's producing a sentence, how does the speaker select a particular expression from the infinite set that's generated by the I language. The next question is, how is that expression externalized in some sensory motor system? Third question is the inverse of that. For the hearer, how is the expression processed, mapped from something in, say, sound to an expression of the I language? Well, the second and the third tasks are input-output problems, kind of problems we know how to handle. And in fact, a great deal has been learned, particularly about processing, also about externalization of the internal object generated. How about the first task? How does the speaker select a sentence from an expression from the infinite array generated by the I language? That's another total mystery. There's nothing to say about it. It's in fact, that's true of voluntary action generally, of which this is an instance. There's basically nothing to say about it. This fact is captured kind of fancifully, if they put it, by two of the leading neuroscientists who deal with voluntary action, Emilio Bizzi, Robert Ajamian. They have a recent review of the state of the art in the field of voluntary action, and what they say is we're beginning to understand the puppet and the strings, but we have absolutely nothing to say about the puppeteer. We can't say anything about why one or another action is selected. In particular, that holds for the first task. So there's another mystery that so far is beyond it. Doesn't even have bad ideas. There's nothing to say about it. Well, the I language is clearly a property of the individual by definition. And the same is true of the faculty of language. Although it's a shared property of humans with insignificant variations, it's essentially a property. It is, in fact, a property of each individual. And the faculty of language faces two empirical conditions, two crucial conditions have to be faced by any theory of the faculty of language, of this internal system. One is the problem of learnability. Second is the problem of evolvability. So the faculty of language has to be rich enough so that it can account for the properties of all languages, and even more strikingly for the remarkable property of this enormous leap from finite data to the internal system, which is carried out by the faculty of language, has to be rich enough to overcome the very acute problem that's called the problem of poverty of stimulus, often unappreciated. So one demand on the faculty of language, it has to be rich enough to have to achieve these goals. But it also has to be simple enough so that it could have evolved. has to meet the evolvability condition, and very more specifically, to have evolved under the very specific conditions of evolution of language. Now, these two goals are, at least on the surface, antithetical. You enrich it, and you enrich the theory, and you make the problem of evolvability harder, and conversely. And a lot of the field over the last years has been some kind of effort to overcome this apparent conflict. So let me stop for a second and talk about the specific conditions under which language evolved, which make the problem much harder and more striking. In general, not very little is known about the evolution of cognition. It's a very hard topic to study. One of the leading evolutionary biologists, Richard Lewontin, has a famous article in the 4-volume MIT Invitation to Cognitive Science. He wrote the article on evolution of cognition, and his basic conclusion is, I'm sorry, you guys, you're never going to learn anything about it. It just can't be handled by the techniques available to current science. Notice, it's not that it's a mystery in the sense of the other things I mentioned. It's just that it's beyond the possibilities of research. If you had, say, tape recordings from 100,000 years ago, maybe you could learn something, but we don't, and we're never going to get them. So his conclusion was there's absolutely nothing to say about it. There's a lot to what he said, and it's worth thinking about, but I think it's a little too pessimistic. There are a few things that have come to light, and they're kind of suggestive. One is that we know that modern humans, anatomically modern humans, there's plenty of fossil evidence that shows that they appear roughly 200,000 or 300,000 years ago, essentially in that range. It's now known that human groups, which were very small at the time, began to separate roughly 200,000 years ago. And the groups that separated have the same faculty of language, as far as we know. San people in Africa, the first group that separated. Well, that tells us that the faculty of language was already established not very long after modern humans appeared. So it seems essentially a property of modern humans as they appeared. Notice that these periods of time are extremely small from the perspective of evolutionary time, which doesn't deal with notions like tens of thousands of years. So essentially we can say that the species characteristic appeared essentially along with modern humans. A second fact known from the archaeological record is prior to the appearance of modern humans, there doesn't seem to be any serious evidence of any kind of symbolic activity in the archaeological record. And not long after the appearance of humans, you start getting quite a rich record of complex symbolic activity. The Blombos cave in South Africa is the most famous example. There's further work on this by a very fine linguist, Rini Hoibrooks, most of you know, who found that he pointed out that the earliest separation, roughly maybe 150,000, 200,000 years, of the San people in Africa, although they have, as far as we know, the same faculty of language, they have a somewhat different form of externalization. As he showed, these are all and only the languages that have complex click systems. So few exceptions, but I think he actually managed to show that they're meaningless. So what that suggests, Rini points out in his article, is that the faculty of language developed prior to the separation, but externalization took place after the separation in slightly different ways. There's some minor physiological adaptation about click languages, slight change in the structure of the palate, but not very much. Well, that's all very suggestive. If you put all of this together, what it strongly suggests is that whatever emerged along with modern humans and yielded the faculty of language must have been very simple and just something that nature would hit upon immediately as soon as some small rewiring of the brain made this task possible of satisfying the Galilean challenge. That converges with developments that have been taking place within the generative enterprise in quite a suggestive and important way. Well, in order to fix it, suppose that in fact something simple did develop along with modern humans, yields the faculty of language. We would expect it to be very simple in structure. And what about the person with dealing with, including very simple modes of computation, which would satisfy the evolvability condition for a genuine explanation? Then what remains to fix a language? Well, an individual has to fix a language on the basis of data, on the basis of simple data, and there must be some way to do this on the basis of very simple evidence. The reason is that we know now from psycholinguistic studies that acquisition of the essentials of language has already been carried out very early. In fact, about as early as you can test. 2 or 3-year-olds have enormous understanding of the fundamental principles of language. I'll come back to some examples of that. And the evidence available to them is very limited. I mean, maybe they've heard a few million sentences, but that gives you extremely little evidence. That's been shown very well in careful statistical work especially by Charles Yang, who pointed out and showed that when you look at the effect of what's called Zipf's law, the rank frequency distribution of words, turns out that almost all the evidence that children are getting are just repetitions of very few things. Even bigrams barely are repeated in millions of sentences. Trigrams almost never, or very rarely. So the evidence is really very slim. The knowledge that's acquired is very rich. We conclude, in general, what we expect to find is a very simple faculty of language, and the actual acquisition of language should be based on some kind of capacity to pick out what's significant and important from quite impoverished data. That's what you'd anticipate. And more generally then, we of course always would be in any field, would be looking for the simplest theory. That's simply a general fact about explanation. It's clear that as the foundations of a theory become simpler, its explanatory depth increases. So if science is interested in explanation, not just simulation, it'll be, of course, looking for simplest theory. There's a second reason for looking for the simplest theory, which is a kind of a precept, goes back to Galileo again, who simply urged that we accept the idea that nature is simple, and it's the task of the scientist to show it. That's true from study of falling bodies to the flight of eagles to whatever you look at. That's, of course, just what's called a regulative principle, a precept, but it's one that's been spectacularly successful in the sciences. So it's simply taken for granted in the sciences, and there's every reason for us to take it for granted too. And thirdly, for linguistics, there's a third reason to expect a very simple theory of the faculty of language, namely the specific conditions under which this faculty appears to have evolved. Well, notice that it's often argued that evolution violates Galileo's precept. Evolution is what François Jacob called tinkering, bricolage, which tries lots of different things, ends up with very complex objects. Whatever one thinks of that, it may not. It doesn't seem to be to apply to the special case of acquisition of language, simply because of the specific conditions under which it seems that language evolved. Well, considerations like these arise very clearly in the development of the minimalist program, to which I'll return. But the point I want to emphasize here is that learnability and evolvability provide the conditions for genuine explanation. That's the Holy Grail. These are the conditions for meeting the Galilean challenge. So genuine explanation will, of course, be at the level of UG, and it will be in a form that meets the demands of learnability and evolvability. That's a very austere requirement. Anything short of that is not a genuine explanation. Anything short of that is a partial account, maybe a useful one, but not an explanation. It's a way of presenting materials as a problem to be solved. That's a very important endeavor. It's much better to have some organized presentation of some carefully structured problem. That's a great advance over just chaos, of course. So it's by no means denigrating those achievements, but we should not confuse them with genuine explanations. Any device that's introduced in linguistic description, any device to deal with some problem, whatever the problem is, has to be measured against these two conditions. Is it learnable? Is it evolvable? I think we're finally maybe in a position today to take the Galilean challenge seriously, which, if true, is quite important. That's a new step. So just to illustrate with a concrete example to which I'll return if there'll be time, there's a very interesting paper by a very good linguist, Jelko Boskovic, most of you know, on the coordinate structure and the adjunct island constraints. And in the paper, he points out that each of these, coordinate structure and adjunct island, pose many problems, many mysteries. But his paper attempts, and I think in a way succeeds, in trying to show that these two collections of mysteries actually are the same mystery. What he does is try to reduce the adjunct island constraint and the coordinate structure constraint to a single mystery, relying on a neo-Davidsonian event semantics, which in fact treats adjuncts as coordinates. So based on that idea, you can take two collections of mysterious phenomena, put them together into one collection of mysterious phenomena, which is a significant advance. That leaves the mysteries, but they're now more susceptible to successful inquiry. And I think that virtually every achievement in the field is pretty much like that. It manages to reduce some collection of mysteries to a simpler and more manageable collection, which is a major achievement, but it's not genuine explanation. So we're still searching for the Holy Grail. At least all of this is the way things look within the biolinguistic program. If you're pursuing a different enterprise, there are different considerations. Let's go on a little bit. There's still a little time. The first proposals, now I'm talking to linguists who know all this, the first proposals back in in the 50s were basically dual. There were two different problems that had to be faced. One was the problem of compositionality. How do you put structures together? The other was the very puzzling property of dislocation. Expressions are heard in one position, but they're interpreted both there and somewhere else. So, what did John see? You interpret the WH phrase, the what, as a quantifier ranging over the whole thing, but you also interpret it as the object of C, where you don't pronounce it. That's a ubiquitous property of language. Very complex cases have been studied over the years. Well, the proposals back in the 50s were two different kinds of mechanisms. A phrase structure grammar for compositionality, transformational grammar for dislocation. You look back at the proposals, each of these systems was much too complex to meet either the conditions of learnability or evolvability, that is, to provide genuine explanations. That was understood, but was very unclear what to do about it. It was generally assumed at the time that compositionality is something natural, that we can kind of handle. Dislocation seemed very strange. You don't build dislocation into formal systems, for example. It's just something that seems unique to language and a very weird property of language. It was considered what's called an imperfection of language. Somehow it adds, for odd reasons, this complex notion. That's still widely believed, but I think it's exactly the opposite of the truth. As research has progressed, it turns out, first of all, that these two apparently different properties can be unified, and that the more primitive of them, in fact, is dislocation. I'll come back to that. But it seems that the most primitive operation is dislocation. Compositionality is considerably more complex, although they can be unified into a single operation, something I'll want to come back to. Well, turning to a couple more comments. Phrase structure grammar was very quickly recognized by the 1960s I'm talking within a particular current of the generative enterprise. Others don't agree. But within this current, it was quickly recognized that phrase structure grammars are completely unacceptable. They're way too complex. A phrase structure grammar, for one thing, allows totally impossible rules. So there's nothing in a phrase structure grammar that says you can't have a rule, say sentence becomes a preposition, verb phrase or something, or anything else you can imagine. So it just allows a huge number of rules that are completely impossible. So there's got to be something completely wrong with it. Also, I think in retrospect, we can now see that phrase structure grammar conflated three quite different notions. One is the notion of just hierarchical structure. A second is the notion of linear order. A third is the notion of what was called projection. How to decide whether some unit you formed is a such and such. And over time, it's been recognized that these are quite different properties. Well, a step was taken by the late 60s to overcome at least some of these problems with the development of what was called X-bar theory. I won't discuss it, I assume you know what it is, but X-bar theory did have a number of consequences, which interestingly were not really understood very clearly at the time. Tim will remember this. For one thing, X-bar theory keeps the structure, has no order, okay? So you have the same X-bar theory in effect for, say, English and Japanese, which are close to mirror images. Well, the significance of that wasn't really entirely grasped. What it tells you in the first place is you have to have a principles and parameters approach. There can't be a rule system, at least for compositionality. Took some years for that to kind of settle in, but it's immediate once you look at X-bar theory. So take, say, English and Japanese, essentially the same X-bar theory, but there has to be something distinguishing them, something that says the order's one way in one language, the other way in another language, but that's a principles and parameters approach. Furthermore, if you look at that parameter, you see that it doesn't affect the meaning of the sentence. So whether you have a verb-object or an object-verb language, the meanings are exactly the same. The theta structure, the argument structure is the same. That at once suggests that the parametric difference, the linear order, simply doesn't have anything to do with the core of language, namely the construction of an infinite number of thoughts. To put it in more technical terms, it doesn't feed the conceptual intentional level, doesn't yield semantic interpretation. That's an observation which has many consequences if you think it through. Well, it's elaborated in later work in other ways, but it's already a bit of a hint that somehow things like linear order and other aspects of externalization don't, strictly speaking, belong to language. A lot of consequences of that when you think it through. I'll return to it. Well, these are some of the consequences at once of looking at X-bar theory. Should have been recognized instantly, gradually. It came to be realized later on. X-bar theory, however, does have problems. I'll mention these and then put the rest off till later. There's a fundamental inadequacy of X-bar theory, which was not recognized. It still conflates projection and compositionality. It does separate order, but it still conflates those two. And that runs aground as soon as you look at exocentric constructions, which are unacceptable in X-bar theory. It rules out exocentric constructions. So you can't have, say, subject-predicate, or you can't have any movement, because all movement yields exocentric constructions. So if you have WH movement, it gives you a construction, WH phrase CP, just two structures, neither one is dominant. Subject-predicate, if you accept, say, the predicate internal subject hypothesis, Dominique Sportician-Koopman, so that you have an NP, a nominal phrase, and a verb phrase, but they're just two parallel phrases. Well, a lot of artificial devices were constructed within X-bar theory to try to get around this and to give you what you intuitively know is the thing you're after, but that's not allowed. That's trickery. So there was a fundamental problem with X-bar theory that finally was resolved, just not recent, a couple of years ago, by the development of labeling theory, which finally separates totally this problem of projection from compositionality, separates all three, tells you when some operation of dislocation must take place, when it may take place, when it need not take place. So that finally suggests, breaks up the conflation of the three notions that were mixed up in phrase structure grammar. A lot of interesting results, plenty of interesting problems. Well, that brings us up until about the 90s. So why don't I stop there and go on next time? Okay.
We have a